Okay, so we start now. Boleh nampak ke the screen? Share screen?
You can see the
Boleh,
screen.
sir.
Okay, for this tutorial, I supposedly I reserve for next week. Today I give you one exercise. The exercise look like this. Okay, like this. Jap. Macam ni. Okay, I'll give you an example. So consider traveling assessment problem. Okay, traveling. Okay, for TSP, I show you simple calculation dulu. Okay, I assume we have three cities. Okay, three cities. Okay, three cities. So I put A, city A, city B, and C. So from A, can go to B, and from B can go to C, and C can go to A. So I assume I just put A to B maybe 100 km, B to C 200 km, and C to A 300 km. C to A equivalent to A to C. Okay, sama C.
Oh,
Okay.
ada lah. Tadi
So,
aku bagi tak ada. Sorry.
The the condition for TSP, the assessment should visit each city only once. Okay, only once for visit the city. So based on three cities, how many solution we can produce? So we can, first solution, maybe we can start at A, go to B, and go to C. Or from A, go to C, and go to B. Or from B, this is random. So starting point, random. Okay, random. B, from B can go to C, can go to A. Or from B also can go to A, can go to B. And C can go to A, can go to B. C go to B, can go to A. So we have 6 what we call solution. So solution mean chromosome lah for
Mana aku?
ni
Selalunya dia dengan kau pagi.
chromosome. So the quality of chromosome we evaluate using this formula Fx summation of xi, I equal to 1 and n or 3. For this case, n equal to 3 lah. Mean from A go to B go to C equal to 300, the solution. And then for this case, minimum because distance. So distance, we our goal to introduce to reduce the price or the price of petrol, for example, reduce the time. So that's why we consider minimum, not maximum. So the best solution mean the lowest value for chromosome. So ACB 500. From BCA, from start B, go to C and CA equal to 500. BAC, B, A and C 400. CAB 400. And CBA is 300 km. So for this case, the best solution or the best quality of chromosome ABC and CBA. Clear? Yes or no?
Yes, sir.
And then because we have 3 cities, so the formula to calculate the number of solution using factorial. 3 factorial mean 3 multiply 2 multiply 1 equal to 6. That's why we have 6 solution. 6 solution of chromosome. Okay, 6. That one for that easy to calculate because number of solution small. What happen if we have 15 cities to visit? 15 cities. So we need to evaluate million of solution because 15 multiply 14 multiply 13 multiply 1. So million of solution. Million of solution. Then that's why to evaluate every single solution from million solution is not practical. Not practical. That's why we introduce EA, GA, PSO, ACO, Firefly, and then Firefly and then Coco search. The goal only one to calculate subset of million solution, but for EA, GA, PSO, and so on, different approach, but the same goal. You should understand the what we call the goal of optimization study for this case. Clear? Ulang?
Yes, sir.
Clear, Doctor?
Yes, sir.
Yeah. And then for 15 15 node or cities, we have 1,000 or million solution. So not practical. That's why for example, we pick up, for example, we set initial solution, initial population, for example, 100 ataupun 500 population or 1,000 population out of from million solution or subset. This one subset of 1,000 or a million subset. subset population, and then for example subset of million 1 million for example solution. This is subset. So 500 population. So how to pick up the 500 population? How to pick up? So we cannot use random to pick up because not systematic. The result not so good. So that's why to pick up we're using this approach, whether using GA, PSO, ACO, and so on to pick up the subset of solution. Okay, then I give you one example here. We have, sorry. Kat sini. We have 9 cities. Okay, 9 cities. 9 cities from A, B, C, D, E, F, G, H, I. 9 cities. Note.
Forecasting and predict sama je kan?
We have 9 factorial. Mean how many solution for 9 factorial? Multiply 8, multiply 7, 6, 5, 4, 3, 2, and 1 equal to, calculate berapa?
362,880.
More than 300
300,000 more than.
More than 300k. Kalau 10 cities, million. Betul tak? More than 1 million. Yeah.
More than 3 million. Yep.
Then this is not practical to calculate. That's why I show you how to solve using optimization for this case. Okay, I assume like this. Okay, we have 9 cities. From A to B, A to C, and so on, we define using this table. For example, you tengok kat sini. From A to A is 0 lah. B to B also 0, 0, 0, 0. But A to B, from A go to B, 10 kilometers, for example. A to C, 20 kilometers. A to D, 30. A to I, 80 kilometers. And then the same for A to B, from column to row, column to row 3, 10, same value. Okay, symmetry lah. This table is symmetry. Then I define the distance for every single distance for each city like this. Then using the formula fitness function, the fitness function fx equal to xi, okay, minimum xi. Then how to calculate the so first using EA, okay, using EA. First, what should we do? We define we set the initial population kan? Ingat tak?
Yes, sir.
Initial population. And then number 2, we
calculate the fitness function.
Yeah, calculate the fitness function. And then number 3,
we do the selection.
Selection. Okay, number 4,
crossover, then mutation, and then we replace the new population.
Okay. Okay, you follow this step. You follow the step 1, 2, 3, 4, 5. Okay, so for initial population like this, initial population like this. Okay, I assume this one chromosome number 1, random by random. For first step, first iteration random, but second iteration not random, based on quality of chromosome. Okay, 1, 2, 3, and this one number 4, chromosome number 4. This one number 4 chromosome. Okay, we set 4 initial population. So from population number 1, we starting point A, go to B, go to C till I. From chromosome number 2, start at point B till G. At point G, chromosome number 3, and then finish at E. And chromosome number 4, starting point D and finish at G. Okay, try to calculate or try to evaluate every single every chromosome 1, 2, 3, 4 the total distance. Cuba you calculate based on this table. Based on this table, you snap this table. The distance, snap this table. Snap, then calculate the chromosome 1, 2, 3, and 4. Dah snap belum? Dah. Okay, so I scroll down
hari ni.
Okay.
Ada event.
Okay, calculate. I nak tengok betul tak yang I tulis kat sini. For chromosome number 1, chromosome 1, the total, the quality, the total distance 346. Chromosome number 2, 270. Chromosome number 3, 415. And chromosome number 4, 255. Sama tak? Cuba you kira based on table that you snap just now. Dah?
So chromosome 4 is 225, is it?
225. Oh, okay. So I silap kira lah. Yang lain betul? 225
Not sure.
Yang lain betul tak? I tak nak ni, I don't know. Mungkin I silap kira kot. Yang lain betul tak? 225 or 255? Not sure. Check yang lain. 255 255 Check balik your answer.
Alright, sorry.
255. Okay, dah.
So dapat 255, sir.
Okay.
Alright, thank you.
1, 2, 3. Same or different? Same word.
Tak kira lagi, sir.
Oh, kira 1, 2, 3.
Kau tengah dalam ni kat yang Google Scholar punya ni? Google Scholar punya event ni. Dekat Google Scholar punya, like they teach you how to use lah. Nak masuk ke? Aku bagi link.
Dah? Dah belum?
Sir, yang nombor 1 tu berapa sir? Saya dapat
255.
yang tu A, B, C, D, E, F, G, H, I.
Oh, yang nombor 1, 346.
Oh, saya dapat 340.
Oh, 40 lah. 40 lah. Mungkin saya silap. Kosong lah sebab tak ada nombor 6 last. 340. Sebab 6 mana ada sebab saya letak 10, 20, 30, 5. 6 tak ada.
Terus orang yang
340.
buat event ni. Letak video before event kuat babi. Cakap-cakap slow bang. Betul.
Nombor 2, 3 sama siap lah.
Nombor 2 dengan nombor 3 saya dapat sama.
Okay, yang lain dah siap. Yang lain dah dapat. Boleh tahu macam mana nak dapat ni? Quality of chromosome based on table. Dah. Okey semua? Yang lain okey? Okay, can I proceed to next step? Boleh?
Boleh sir.
Okay, sir.
Okay. Then, based on this, what we call chromosome 1, 2, 3, and 4 ni. So the best, the what we call the quality ni, the best chromosome number 4 and chromosome number
2.
2. So we put chromosome number 4 and 2 as a parent. Okay, then as a parent, then using what we call the next step after we decide the parent. So we do the crossover, then add point by random, and then because you set 4 population, so you need to do 2-time crossover to produce 4 children. Betul tak? Then same parent, but you just change the what we call crossover point. Maybe the first crossover you using second point of chromosome. Then for next crossover, maybe you set at point number 4. So you can get for two crossover, so you can get the 4 children. Then you evaluate again what we call the chromosome. Before you evaluate, you need to do the mutation. For this case, mutation, you just swap like this. By random also, from D go to A, and A you change to D, the location of gene. So you cannot flip, because for example, katalah you flip kan, katalah this ni A B C D E F G H I, you flip this chromosome, you change to A. For D you change to A. So this chromosome invalid because A occur 2 times. The condition for TSP occur only one. But for this case, occur 2 times, twice. So that's why we flip. We swap. Swap mean from D you what we call change to the location, you replace, and from A go to D. So maybe here D and A kat sini. Clear?
Yes, sir.
So
Yeah.
after mutation, you evaluate again. Evaluate using the same step. The finite function, finite function, the quality of chromosome. So maybe this one 350, for example, and so on. Then you compare. For comparison, we have 6 parent to 2 parent and 4 children. 4 children. So chromosome, 2 parent and 4 children. So kalau parent, the result better than children, so the children don't consider, just consider parent. But children better than parents, so you consider parent. Clear? Then that one for first iteration, then next iteration, third iteration, and so on. You follow the same process. I nak you show the 3 iteration process minimum for using 4 population using AA. So I nak you what we call using how to explain. Then you need to you need to show me the process, the calculation, manual calculation, how to calculate, how to solve this problem using AA. Clear? Apa nak kena buat for today?
Clear, sir.
Clear kan? So
Clear, sir.
So I nak you buat sekarang. Then anything, communicate through WhatsApp. Then simpan the result. Show me next class tutorial next week. Nanti I just random random ask siapa yang nak present. Tak boleh jawab, I potong markah. So make sure you all be ready lah. Nanti you gonna share screen. Maksudnya you need to share screen your work. Macam mana you solve this problem using example that I give the problem. So macam mana nak buat. Then tak semua orang kena present, just beberapa orang je. I nak tengok you punya solution macam mana you solve. Tapi be ready lah. Kalau yang kena tu nasib lah, tak kena. Mungkin next tutorial kena. Kalau tak buat, I negatifkan terus. 2 markah negatif. Nanti negatifkan. Potong 2 markah. Okay, clear?
Clear, sir.
Yes, sir.
So make sure you buat sekarang. Kalau anything, WhatsApp through ni lah, WhatsApp. You text me through WhatsApp.
Sir,
Alright? Yeah.
can you explain again the selection process?
The selection process, for example, we have 2 parent. Kan, we have 2 parent. Macam ni, parent like this. 2 parent, we select the best kan. Yang tadi we have for this is the first iteration. First iteration we have chromosome 1, 2, 3 and 4. So the best chromosome number 2 and chromosome number 4. Macam ni. Okay, so for the next iteration you need to what we call to produce new population. So first, because of we have 2 population here, so we need to randomize the point of what we call point of crossover. So maybe at point number 3. So below at point number 3, A, B, C and D. So can produce A, D and C, B. Betul tak? Nak faham? Faham ke tak?
Oh, okay, so pick the best 2 and then generate 4 new offspring.
Yeah,
Yes.
Lepas
Okay.
tu, lepas and then one crossover. Second time, so you random again the point of ni crossover ni maybe at this point. So maybe prime, B prime, C prime and D prime. So you can get A prime and D prime. And then satu lagi crossover, C prime and B prime. So at different point, maybe point number 3, this one at point number 4 and so on lah. So we have 4 population here. So because of so we have 4 population, so we need to evaluate again. So we evaluate population ni maybe 200, this one 300, this one 400, this one 500. So the best population, this population, maybe we name that this population is number 3. This one population number 4, population number 5, population number 6. So population number 3, 200, and then population number 2, population number 4, 3 and 4 the best kan. So you consider 3 and 4 as a parent for the next iteration. Clear?
Okay, so from the 4 new offspring, just use all of them as the next generation and then generate new offspring.
Yes.
Is it like that?
But
Okay.
before you generate next new offspring, you should consider the quality of chromosome for parent. Make sure children better than parent. If parent better than children, so you consider parent for the next parent. Clear?
Okay, so just replace everything from the previous generation with the new one?
Yep.
Okay, replace everything. All right. So last question for the chromosome AD and then A prime, D prime. The difference is the location of the crossover, or is it because of mutation? The difference in
okay. The different for crossover.
The crossover.
Point of crossover.
Okay, point of crossover. Okay.
Yep.
So the same type, let's say a single point but
Yep.
different location.
Yes.
Okay.
Different
Okay.
location of crossover point.
Okay, I think I get it. Yeah. Thank you.
So show me 3 iteration process for this problem. So next week, show me your work. Okay? Any question? Yang lain? Ada?
No question from me. Thank you.
Sir, point of crossover point tu kita choose randomly, right? Kita boleh
Crossover randomly.
Okay.
Crossover point randomly. Okay?
Okay, that's it.
So make sure you snap this table. Snap this table. The value of A, B, A, C, and so on. Then snap the initial population, 1, 2, 3, 4 chromosome, and show me the process for 3 iteration. That's all for today. So see you next week. Assalamualaikum.
Waalaikumsalam.
Anything WhatsApp? Anything WhatsApp? Anything WhatsApp? You want to ask me something through WhatsApp? All right, bye.
Thank you, sir.
Bye.
Thank you, sir.
Bye.